This video describes a robot called Whegs 2, which is the second in a series of simplified, cockroach-inspired robots developed at the Biologically Inspired Robotics Laboratory at Case Western Reserve University. Whegs 2 is a highly energetic robot that takes advantage of abstracted biological principles and reduced actuation to accomplish agile locomotion over challenging terrain. Locomotion is accomplished through the use of 6 Whegs, which are a combination of both wheels and legs. These devices allow the robot to walk with a cyclic leg-like motion over challenging terrain while being powered by only one drive motor. Whegs 2 is 47 centimeters long, 36 centimeters wide, and weighs 3.9 kilograms. It can travel at speeds up to 3 body lengths per second and has a turning radius of 1.25 body lengths. Studies of cockroach locomotion have highlighted 3 important abstract principles that, when implemented on Whegs 2, enable the robot to achieve efficient walking over various types of challenging terrain. Cockroaches nominally walk in a tripod gait, with the front and rear legs on one side of the body moving in phase with the middle leg on the opposite side. Whegs 2 also walks in a tripod gait over flat terrain, with contralateral Whegs 60 degrees out of phase. The use of 3-spoke Whegs is a compromise between climbing ability and smooth walking. Further studies have shown that cockroaches change their gait when confronted with large obstacles. The animal moves both its front legs in phase to reach the top of the obstacle at the same time, thus resulting in greater stability. Whegs 2 is able to passively adapt its gait when climbing large obstacles. Torsionally compliant devices in each axle permit contralateral Whegs to come into phase, allowing the robot to climb barriers more effectively. A preloaded spring prevents the Whegs from coming into phase on flat ground and returns them to their original facing after an obstacle is surmounted. Cockroaches make extensive use of body flexion to more efficiently traverse large obstacles. By pitching the front of its body down while climbing, the animal gains positive footholds and avoids high centering on narrow obstacles. Whegs 2 exhibits the same behavior, flexing its body joint to help it climb over large obstacles with little difficulty. In order to reach their front legs onto taller obstacles before a climb, cockroaches pitch their bodies up by rotating and extending their middle legs. Whegs 2 is able to extend its body joint while walking, allowing the robot to raise its front legs and reach the top of obstacles that it would otherwise not be able to reach. This behavior results in a dramatic increase in the maximum height of an obstacle that the robot is able to surmount. Using only one motor for propulsion results in a very high power-to-weight ratio. Whegs 2 is a highly energetic robot that makes use of abstracted biological principles to enhance its locomotion abilities. It is a useful research platform that is inexpensive, agile, powerful, and robust.
Oh, okay.